Hey guys, so this is video 2. This is a follow-up to your lesson 4 notes on finding an inverse. So this is an alternative note page that I'm going to have the sub give you. My recommendation would be for you to write all this stuff down first and then come back to this video so that you can follow along with me. I will let you know that my expectation is not that you can necessarily graph perfectly. It's just so that you can find an inverse and then know when to restrict the domain or not to restrict the domain when it comes to a quadratic function. So basically these notes, you can find them in the alternative. So it's listed as lesson 4 alternative notes in Canvas, and it's after the blank copy, and you should have gotten this note page from the sub. So I'm going to talk about how do you find an inverse and when do you need to restrict the domain and not restrict the domain. So I'm going to kind of go through these pretty quickly. So these are just the steps. You'll notice that these steps are a little bit different than the steps that I gave you in the back of your OUR packet, but they're very, very similar. So the main difference is switching X and Y after instead of switching it before. So it doesn't really matter either way when you switch it. So that's why on these notes it says switch it at the end. The one thing I do want to note though is it does have you bring in the inverse notation, and you do want to make sure anytime you are writing the inverse function that you are using inverse notation, and that's with the power to the negative first power. Okay. So we're going to look at these, and like I said, our main focus is for you to be able to write the inverse, not necessarily to graph it, but I did want to show you what the graphs would look like so you have a better idea of what the cubics and the cube roots and square roots and square root functions would look like. So we have this first function, so we're going to go ahead and change it to y, and then we're going to undo the operations. So since we see a minus 2, we're going to add 2, and since we see to the power of 3, we're going to bring it to the cube root because we want to do the radical that is the inverse of the exponent. Okay, so our inverse is the cube root of x plus 2. There are no domain restrictions because it's a cubic function. The only time we have to restrict the domain is when we're dealing with a quadratic function, or basically anytime there's an exponent that's even. Now we're not going to really deal with exponents of 4, 6, or 8 in this unit, so just know that you're not going to have to really worry about it too much except for when you're with a quadratic function in this unit. And for the graphs, I just use the -2, -1, 0, 1, 2, and then I flip them like our normal, and then I graph them as follows. So again, the focus is not necessarily the graphs, but it's to write the function. Okay, so we have our first quadratic here. And so our quadratic, we are going to do our same steps as normal. We're going to divide by 12, and then to get rid of the exponent, we're going to square root. Because we had a quadratic to begin with, we do have a restricted domain, and I'm going to talk about how we find that restricted domain in number 3. We're going to have more practice with this as well when I come back, so don't stress about it too much, but the domain is going to be from x is greater than or equal to 0. So what that means is that when it comes to the graph, I'm only going to be graphing the points where x is greater than or equal to 0. So you'll notice that I only graph the last 3 points instead of the first 2 points. If you look at the next one, this is also a quadratic. So again, this one's a little bit more involved, and we'll have more practice with this as we go along, but we are getting rid of the positive 3 by subtracting it. We're getting rid of the negative by dividing by -1. You'll notice that I changed the signs here. And then we're getting rid of the exponent by taking the square root. And then lastly, we're adding 1. Now, the most common mistake a lot of students make is they want to add the 3 and the 1 here. But because 3 is in the radical, you can't, so it has to stay separate. Now, let me explain how you do the domain restrictions. Once you get it into a radical, you essentially set whatever the radicand, which is what's underneath the radical, it's going to be equal to or greater than 0. So you'll notice we have -x plus 3 is greater than or equal to 0. So we minus 3 to both sides, and then we divide by -1. Now, because we're dividing by a negative, the inequality sign flips, and so our domain restriction is going to be x is less than or equal to 3. And so we're going to be, again, only using the last 2 points. Now, you may say, well, wait, Ms. Strickland, 2, -1, -6. These are all points that are also less than 3. But you have to realize that we're going to be using only part of the function. And again, I'm going to go more in this when we come back. So we can only use the parts that were original to the original function for our function that's here, okay? So our next function will look slightly like this. And again, I know this might sound confusing, but again, don't worry too much. We're going to practice it more when I get back. The last one is a cube root. So again, there's going to be no restrictions. So we're going to undo all the operations here. So we raise it to the power of 3 because that's the inverse of a cube root, and then we add 5 and we have our inverse function. Now you'll notice that I didn't use the -2, -1, 0, 1, 2 here, mainly because it's a cube root, and so we would have a lot of decimals, and so I wanted you to see what the function really looks like. So I very intentionally used the -2, -1, 0, 1, 2 for the inverse, and then I flipped it for the original so that it worked a little bit more cohesively. So again, goal for today would be for you to have a little bit more understanding of how do we get, or how do we find that inverse. So what I want you to do after today's notes is hopefully be able to go back to your 2 lessons. So the first lesson being your lesson 5, Ready, Set, Go. So the ready we already worked on Tuesday. That's just converting it to rational exponents and combining like terms if you can. But the set, finding the inverse of the equation. So like for instance, number 12, number 14, and then finding the composition of functions for these two. Hopefully you would be able to kind of plug one in and see if they're inverses as far as the Ready, Set, Go goes. And then also that packet that you guys also had, let me go ahead and find it real quick, but the packet that was your white packet that had 2 pages, hopefully you can go back to some of those problems and you can now actually answer how do we find the inverse of things. So the problems here for 9 through 19, essentially, you can go back and find the inverses of these, okay? So I am going to make the Ready, Set, Go for lesson 4 and 5 due on Friday, and then I'm going to have you turn this one in next week on Tuesday. And then again, please feel free to reach out to me if you have any questions, but hopefully you can go back and work on these now that you have a little bit of notes on them.